Good morning.
Hey, Lauren, it's Michael. How are you, sir?
I'm fine. How are you doing?
Doing well. I'm going to make you a co-host here so you can have all those powers.
I am hosting today, so Lowell will be online, but he's not able to do the sharing and the hosting. So
No worries. And sorry for the flurry of emails. Lowell gave me a call about an hour or so ago and mentioned he wasn't sure how to get the Zoom up and running, so I had to resend some invites.
yeah, no problem. Yeah, I couldn't figure out how to do it myself either.
All good. I'm putting together some documentation that I think might be useful. We'll share that out when it's ready, probably next week.
Okay, sounds good. Yeah, always used to having, all the invites have all the links and it's all copacetic from the very beginning. So I never had to do that with the telco or the edge stuff. But good to know how to do it in the back, in case something's not right.
Perfect. And I saw that we have a call on Monday around the EMEA summit, so that's
Yeah, no,
fantastic.
I'm gonna do some work tomorrow and over the weekend on the looking through the papers and stuff.
And we ask a lot of you guys. Appreciate it.
That's fine. And I'm talking to my boss about whether I can go to the both the EMA summit and the Canada Day summit or Canada Day Tech Day.
Like you'll have to try and structure in like a Mediterranean cruise or something following the EMEA summit. You'll be right there in Barcelona. So,
Actually, one of my other managers is scheduling a trip to Shanghai and Thailand a couple weeks before that. So Barcelona may be on my way home.
oh wow.
We'll see how that works.
I go to China once or twice a year and really enjoy it, but I've never been to Shanghai. Need to go.
Shanghai is a very cool city. It's got huge European flavor to it because one side of the river was, pre or colonial and all the buildings are still there. And it's one side's, very kind of old and old school, and the other side is all these huge, tall, modern buildings.
Oh my goodness.
Yeah.
I really only know Beijing and Shenzhen, believe it or not.
Yep. Been to both those places too over the years. Haven't been there like, I think last time there was like 8 years ago or something like that. I haven't had to go there recently.
Got
Hello,
folks
James.
filtering. Hey, James.
Hey guys, hope everybody's doing well.
Yeah. Small crowd today so far. Hopefully, folks are just still filing in.
Yep, we'll see. Do you know how big the mailing list is for?
I do. We are looking at 102 people.
Okay, cool. So Lowell should join probably via phone. He's like off doing stuff, errands and such that he needs to do. Um, and I'm here sitting in my car with my PC, able to host.
That's great. Starting to get some folks filter in here.
Hello, Ashok.
Oh, hi, Lauren. Hi, everybody.
I assume you guys can all see my screen.
Yes.
Good. So why don't we just sort of get started here? Just some introductions to make sure everybody knows who's on the line here and what their roles are. Um, and then we'll go through a set of topics that you can see here. Um, so my name's Lauren Staley. I'm one of the co-leads of this initiative. Lowell Lamb is the other one. He's from Broadcom. I think he'll be joining us shortly, but he's off doing something that's has a conflict at this time. So I'll be leading us through the presentation, the meeting today. Why don't the guys from OCP identify yourselves and introduce yourselves to the rest of the folks here?
Yeah, sure. Thanks, Lauren. So, folks, my name is Michael Schill. I work on the community side of the house at OCP. Great contact if you have any questions about getting involved or general OCP questions. Here for support today.
Yep. Hey, I'm James Kelly, VP Market Intelligence and Innovation at the Foundation. I've got a technical networking background and was kind of involved in this strategic initiative since it kicked off last year. So I think many people have seen me around these calls more often than not.
Thanks, James.
I'm Russ Wunderlich, Principal Engineer on the Foundation staff, here to listen, learn, and support you where I can.
Sounds good. Ashok?
Yes, hi, my name is Ashok Raman. I work at Broadcom and I'm a colleague of Lowell's. We work in the same group, and I'm here helping him out with some of the nitty-gritty details of these various platforms that we are investigating. I played the same role in the 400 gig submission.
Yeah, definitely.
Yes, that's it. Nice to meet you all. I look forward to working with all of you on this initiative.
All right, I guess that's it for now.
Okay.
Given who's on the line right now, we may go through these slides fairly quickly, unless other people join. What time is it? 5 after?
Yeah.
Well, let me wait a couple more minutes and see whether anybody else joins here. And then our next meeting is 2 weeks from now, so we're meeting bi-weekly. And I think Lowell and I will try to do some drumming up some more attendance between now and the next meeting. So I'll go through this fairly quickly. Please stop and ask questions if you're not familiar with the material. Um, we have specified an open cluster, and this involves two things. One is an overall cluster, and then a pod group that is a basic building block for the clusters. Hello, John.
Hey guys, sorry I'm late.
That's fine. I think everybody knows you on the call here at this point. So first attempt was the one on the left. This is the 400 gig air-cooled open pod group. And you might take note that this was based on, existing equipment that was based on 400 gig interconnects. And actually kind of the overriding principle of this was that most of these were based on industry standard servers, large ones with additional set of 8 GPUs included in the server. And so Supermicro, Dell, HPE, others built these kinds of nodes for AI compute. We are starting to work on 800 gig, which is very different. The 400 gig is air cooled, the 800 gig looks to be liquid cooled, and we'll talk about that a little bit more. But there will be changes between the 400 gig architecture and the 800 gig architecture based upon what kind of nodes are being developed to put into this kind of 800 gig structure. Um, we go through equipment specifications, space, power, cooling, and weight. So we try to give an overall, picture of what it takes to actually implement these open pods. And in the current one, the 400 gig, there's an open pod set of racks that's on the left here. And then it's added, or there's a spine aggregation level that actually creates the cluster of pods. And again, it will be different for the 800 gig liquid cooled versions. For the 400 gig, we specified the cluster and all the networks that are involved there, and there's many networks in terms of both scale up, scale out, and then there's separate networks for connecting CPUs together, connecting storage, and a couple of different management connections, out of band management and in band management. And a lot of that stuff connects to what's called head end nodes here, which is kind of the set of additional equipment that's used to manage um, access and deploying applications onto the cluster. And that has a whole set of requirements that Ashok in particular and Lowell, researched in terms of not just what it takes to build an AI cluster, but what it actually takes to be able to interact with it and manage it. And again, there's probably going to be changes. One of the things you'll see with some of the 800 gig.
Hello, is it me or have we lost Lauren's audio?
I think Lauren's audio did
To
just
get
drop.
to that sort of world. Pardon?
Lauren, we lost you for just the last couple of
Oh, okay.
seconds. Do you want to go back to that?
This slide in particular?
Yeah, just about 20 seconds.
Okay. Yeah, so this is the networking architecture for the 400 gig, and you can see it's got like all the networks that are involved here, and there's many. Besides the scale up network, there's a scale out network that's part of the pure data path for the cluster. Then there's other networks that are related to storage, connecting CPUs together, and then management, both in-band and out-of-band management networks. And a lot of this stuff connects to head-end nodes, which is an additional set of equipment that's actually used to deploy applications into the AI cluster and manage, connectivity to users and to the internet, typically. We did a full set of topology and connection maps. So this actually specifies very directly how you connect all the equipment together. And again, this will change for the 800 gig because of the different set of equipment that um, companies are bringing to the market. And we'll talk about that in a second. In addition, there's hardware kits. And this just describes kind of the overall set of how many number of different kinds of pieces of equipment you need to actually build the clusters that are illustrated and in the white papers. And then we do software management guidance. So our starting point was actually trying to leverage, especially the BMC, open BMC code and the standardized BMC hardware. But there's a whole host of software, and a lot of it is supplied by vendors or expected to be, the application and actual models that go on the cluster. A lot of the switches, most of the switches in it, we recommend Sonic, just because that's another open segment that's associated with OCP. So Sonic, OpenBMC, kind of the base for management and networking, and then the rest is guidance for how to where to expect to get software for the various pieces in the cluster. 800 gig reference architecture. This is kind of the kickoff. And we're kind of Lowell has laid out trying to follow the same kind of procedure we used when we were building the 400 gig air-cooled instance of this. So we expect two new publications, Open Pod Group for 800 gig, and Open Cluster for 800 gig. We have a third white paper that's kind of the project white paper. We don't need, I don't think we need to update that, but we'll review that as we go along here. And so we will start the discussion over the next couple of weeks with the OPGM, which is the Open Pod Group for 800 gig, the basic building block for 800 gig. And Ashok, if you want to, I think you were participating in part of this, so if you want to just kind of describe where we're at in terms of um, this initial node.
Yeah, no problem. I can talk to this slide. So basically, we did the way we went about the 400 gig rack discussion was to do a survey of what was available from various manufacturers. And this table summarizes the data that we found in terms of most of these systems that were available then for the 400 gig series was XPUs were available in units of 8 as GPU servers or XPU servers. So, and then I'm not going to go through every line item, but in our survey, we found what the number of XPUs was, what kind of CPUs they typically had along with the servers, what the bandwidth of the scale out NICs were, how many NICs per server, and so on and so forth. Okay, and so we found out that there were scale out NICs, front end NICs, storage NICs, out of management ports, and then each of the dimensions of these different servers, the maximum number of nodes per rack, are basically also focusing on the fact that our goal was to kind of say that, hey, enterprises already had existing data center capacity, and they were probably not going to be building out the tier two type enterprise data centers that were the targets for the kind of work that was done here would not be ripping and replacing their entire power infrastructure. And so we kind of try to understand what the power constraints were in existing data centers, and that gave us an idea of how many such a GPU, how many GPUs per rack, how many GPU servers per rack could be accommodated, and how many therefore pods we could build. So that was the motivation for this, and that led us to the conclusion that the numbers that we came up with made sense in the context of building a GPU pod of about 4 servers per rack, and then 8 servers could create an individual OPG pod. And then we connected a bunch of these per servers together to build this XOC cluster. So these were some of the, for example, most all of these servers had multiple networking infrastructure elements. So they had the scale out NICs, they had the front end NICs, out of band management ports per NIC. Most of them had 2 Ethernet ports per NIC, but not all of them exclusively. I mean, there were some with 1, which went up to 10 gig, but the vast majority of them were some variant of 2 or 4 gigabit Ethernet ports. And then the dimensions varied, but they were all in the 4 to 8 RU per server, the maximum number of nodes and the power supply, etc. So this was based on collecting data from widely available servers in the industry. We have not identified the specific manufacturers here, but as you can see, these manufacturers are well-known tier one type manufacturers. You can assume they'd be the likes of Dell, HPE, Supermicro, and so on and so forth.
And you can see on the right-hand column there, we kind of supersetted the solution to accommodate all of the variants here. And that was what came out of that set of equipment. Obviously, our target here is tier two enterprise and colo suppliers that aren't the hyperscalers dedicated data centers. So kind of a more common environment that exists. Obviously, that will change when we go to the 800 gig liquid cooled. There's lots of supporting infrastructure required for that. I'll turn it back over to Ashok, and here's kind of the under construction 800 gig set of stuff.
Yeah, so same thing here. We've just started this survey to understand what is available today. And of course, the data for this is a lot sparser, or rather, our work has just begun. So we need to fill in this data. So Lowell and I have started looking at what is available in the marketplace today. And we have identified manufacturers. Then we are trying to understand, almost all of these are some variant, to be completely blunt. Almost all the solutions we found in the market are some variant of basically the NVIDIA NVL72 architecture and the upcoming AMD Helios rack architecture, right? So most of them seem to be now based in coming up with 72 XPUs per rack. And we're trying to understand how many scale out NICs they have per tray or per rack, whether the scale out, what does the networking infrastructure look like. In the 400 gig generation, what we did was in our specification, we called out explicitly all the different types of networks separately. But I think what we are finding out more and more is that in this generation, we have to rely on what is called converged Ethernet. That means maybe the in-band and the storage networks are merged into a single front-end network. Or the front-end network consists of multiple elements. It's a converged Ethernet, but it supports storage connectivity, it supports in-band management connectivity, as also connectivity to the internet and so on and so forth. So we try to identify that, but ultimately there are still a few elements that seem to be common. There will be scale-out NICs. There will be, what we call the NVLink equivalents, which is the scale-up NICs, but we are not calling that out specifically as an element. But all the racks certainly have multiple trays that are dedicated to scale-up connectivity as well. And these are much heavier in terms of the weight, as you can see, and they consume a lot more power.
A
Each
lot more
rack is
power, a
now
lot more
consuming about
cooling.
120. Yeah, and also, of course, they need a lot more cooling as well.
So yeah, so the power and the liquid cooling are kind of the backdrop of, what these sets of systems need to actually be run and deployed. And so here we'll start with this. 2 weeks from now we'll come back to this discussion about the pod design based upon more detail on the survey here. Any last comments, Ashok, before we move on?
No, and if anybody, of course, our request to the team is if anybody here has any specific knowledge or insights and would like to contribute here, please reach out to Lowell and Lauren, and we'll figure out. Hopefully, we can leverage your expertise in getting some of these entries updated.
So that's kind of the overview of where we're at, where we're going. Any other topics or questions from anybody on the line today?
I see that Lowell is now online. Lowell, do you want to say something?
Oh, sorry I'm late. I just had trouble getting in, but I'm in now. So no, it looks like it's going well. No comments. Go ahead.
So, when we did the 400 stuff, Lowell was very good about putting together kind of an overall topic and schedule to try and make sure we get to a draft of these designs. So here's kind of the proposed working group schedule and agendas. And you can see that this comes in, and we're trying to get stuff kind of ready for review before the OCP Global Summit in October. So over the next months, every 2 weeks, we've kind of got some topics here. And as I said, the 2 weeks from now, we'll come back to this 800 gig work plan review, and we'll talk about the 800 gig pod kind of reference design, hopefully with more detail than what we presented here today. And I think that's it for today.
So Lauren, these are revisions of the current contributions or completely
These will
different
be
documents?
two new documents that are going to be created and contributed. So just like we had a document for, go back up here. Let's see. Yeah, here. So just like we had open pod group for M XPUs for 400 gig and an open cluster for N XPUs for 400 gig, we'll have these two documents for 800 gig for this liquid cooled 800 gig architecture. That make sense?
It does. I think where I'm a little disconnected is the original white papers were released at 0.2 revision. And I have in my notes that there was discussions of versions to, sorry, I got to flip back to my notes, 0.8 and 1.0. And so I'm not so sure if that's prior plans not following through and this is new material, or that's adjacent.
I will let Lowell answer that question.
No, yeah, maybe we, weren't clear. It was always our intention to prepare, separate documents for the air-cooled generation. So we got that published in January. So those are done and dusted. But, we recognized at the very beginning of this last July that there was enough difference, in fact, fundamental difference in how these systems are put together, that we would need to basically start over for the liquid cooled system for the 800 gig. So we're doing the 400 gig documents are now on the shelf and they're ready for use. And now we'll put up on the shelf next to them 2 more documents for the 800 gig.
Okay, so will I follow and have no objections, concerns to the 800 gig direction? I think where I'm still kind of, your statement is at a revision 0.2, those documents are done.
Yeah, the ones that are currently on the website available, those are done.
Okay.
The 400 gig documents are done. Yes.
Done and never to be revised.
Well, if it really comes down to what the market requires. I mean, we've created them, we've put them out, and if the community comes back and says this is great, but we need fixes because of whatever has happened in the market, then this group can consider revisiting those 400 gig documents. But I think it's now time, and it's appropriate to put them out there and to get feedback from the community. So we're done for now.
Yeah. Do you want us to make them 1.0 versions to be more consistent with others?
Yeah, I think, Lauren, that's where, from my notes, right?
Yeah.
Hey, no problem with the 0.2. That's a very early revision. You expect incremental improvements from that. And again, my notes showing, hey, there was supposed to be a 0.8 in Q3. These are just my notes, right? And 1.0 in Q4.
Okay.
So when I did reviews, inputs, it was, there's another rev coming up at least. I'm not asking for any changes. I think maybe perhaps I should have dug in a little bit further on, because there was mention, hey, next version will be liquid and 800. So that was all apparent in those discussions. I think I just, maybe I didn't do enough digging to help understand what revision this should have been at then. I don't know that we have to change anything.
Okay, I think actually, my memory is not perfect, but if you actually open up the documents on the OCP website, both of them, like both of the 400 gig documents say 1.0. I think
they do. Okay.
That is, I just posted the snip of that in the chat here in the meeting.
And they're all one?
Yep.
Okay. The review copy I just pulled up was labeled 0.2. So maybe that was something that was.
Yeah,
thank you.
Yeah, check the website. Okay. Go ahead, Lauren.
I think that's it.
All right. No, I think what I would say is we're all looking forward. Thank you very much for all the great assistance and collaboration we had getting the 400 gig stuff done. So we're, this should be a very interesting project, and we really welcome everybody's assistance on this.
Yep. Thank you for your support on the OCP side. It's been very good, and we look forward to working through this. This is interesting. I actually didn't realize there was that much commonality on the liquid cooled 800 gig equipment and stuff, but it looks like the 72 per rack is kind of the point. One comment is, I know that going forward, there's a lot of companies building chips where they're trying to, get rid of even that kind of structure and go to full mesh of GPUs between multiple racks and stuff. So this, at least there's some structure to this 800 gig liquid cooled equipment that could be useful to more than just hyperscalers. And we'll try to, comb or ferret that out from what we initially see there in the chart. and try and make it useful for, more of the community and more different kinds of customers. All right. Any other questions, comments? I think we're done for today. Much appreciated.
We're gonna
Thank
have
you,
this
everybody.
recording
Sorry.
posted.
Yes, all this will be posted. Absolutely.
Okay. Sounds good. Thank you.
Thanks, guys. Bye for now.
All
Thanks,
right. Thank
everyone.
you. Thanks, James.
So,
Thanks.
bye-bye.